Okay, these examples are for example 3 in chapter 1, lesson 5. Actually, we're going to start with question 2 here because it's actually the easier of the two questions. This says find the measure of angle MSN. Well, if we go over to our figure here, MSN, this is real simple. We've got that little box in the corner, and as you all know, that means 90 degrees. So that's an easy one. Number 1 is a little more difficult. Because this is 90 degrees here, these two lines are what we call perpendicular. That's what this upside down T mark is. It says find the value of x and y so that line NR is perpendicular to line MQ. Now, line MQ is the horizontal line, line NR is the vertical line. And we know that they're perpendicular, or 90 degrees to each other, because of that box. So that must mean that if we have one right angle, all four of these angles are 90 degrees. So that means if I want to find y, all I have to do is take 9y plus 18 and set that equal to 90. And that's what I'll do right now. 9y plus 18 is equal to 90 degrees. And then I just go through and solve that. Subtract 18 on both sides. That goes away. I'm left with 9y equals, and then 18 from 90 would be 72. Or divide by 9 on both sides to get rid of the 9 and leave me with just the y. Y is 8. Okay, that wasn't too hard, but now we have to find x. These two angles over here on the upper right side corner add together to make 90 degrees. So 5x plus this x degrees here should add together to make 90 degrees, because I know that this line and this line form a 90 degree angle. So what I have to do for this one is I have to add these two angles together. So 5x plus x equals 90. So to solve this, I combine my like terms. That's 6x equals 90. And then divide both sides by 6. And x then is equal to 15. On to the next example. This one gets a little more complicated. If the measure of angle EBF equals 7x minus 3, and the measure of angle FBC equals 3y plus 3, find the value of y so that BE is perpendicular to BC. So what we want to do is we want to make sure that this is a 90 degree angle here. So angle EBC will be 90 degrees, and angle EBA will also be 90 degrees. Alright, let's put these expressions in where they belong. EBF is this angle right in here, and that is 7y minus 3. And angle FBC is this angle right in here, and that is 3y plus 3. Okay, we can see that both of those angles, if I were to add them together, should equal 90 degrees. So that's the equation that I'm going to set up. 7y minus 3 plus 3y plus 3 should equal 90 degrees. Again, I'm going to combine my like terms. So 7y plus 3y is 10y. And then when I combine the numbers, negative 3 and positive 3 is 0. So they cancel each other out. They're gone. And I'm left with just 10y equals 90. I will divide by 10 on both sides. That'll eliminate the 10 in front of the y, leaving you with just y. And then 90 divided by 10 is 9. On to our third. Same picture, but a new problem. The measure of angle EBF equals 3x plus 10. The measure of angle DBE is x. And BD is perpendicular to BF. Find the value of x. So let's mark up our figure here. BD is this ray kind of going off at an angle, and then BF is this one going off to the right. These two are perpendicular. That means 90 degrees. So this is a 90-degree angle here. Now let's label our angles. Angle EBF should be 3x plus 10. So this angle is 3x plus 10. And DBE, which is the smaller angle right in here, that is just x. Now those two angles added together should equal 90 degrees. So x plus 3x plus 10 should equal 90 degrees. Again, combine our like terms. So 4x plus 10 equals 90. Subtract 10 on both sides. 10 goes away on the left, leaving you with just 4x equals, and then 90 minus 10 is 80. My last step is to divide by 4, eliminating the 4 in front of the x. X equals 20. And I'm looking for x, so that's my answer.